let's jump right into this explainer. We are literally hurtling toward the year 2050. And guys, the staggering projections for global resource demand are a massive wake-up call. I mean, the decisions we're making right now, they're going to lock in our path for generations. Let's dive in and see just how monumental this challenge really is. 2 billion. By the time we hit 2050, the number of cars on our planet is expected to double to 2 billion. Just think about that. If we stick to our current trajectory, that would triple fuel consumption and massively blow up our carbon footprint. We're actively pulling up carbon that's been safely stored underground for millions of years and burning it straight into the atmosphere. If we don't curb that, we could trigger climate changes that we just simply can't recover from. And that brings us to this incredibly pressing reality. We are in a race, and the race is against time. We aren't just racing other countries for economic dominance anymore. We are racing the clock to prevent irreversible environmental damage. The sheer scale of what we're up against means we've got to completely rethink our approach to energy, literally from the ground up. So, to survive this upcoming resource crunch, we're going to explore 3 distinct pillars today. Number 1, engineering the future fuel. Number 2, reinventing how we drive. And number 3, building the cities of tomorrow. Okay, Section 1, engineering the future fuel, moving beyond petroleum. Let's get right into it. Liquid fuels are pretty much unparalleled in their energy density, right? That makes them absolutely necessary for heavy transport, like massive trucks and airplanes, where standard batteries just aren't going to cut it. Now, the differences in how we actually create biofuel are honestly kind of staggering. In the US, producing ethanol from corn yields a 1-to-1 energy return. Basically, we aren't gaining anything. But then, look at Brazil's sugarcane ethanol. They get 7 times the energy out compared to what they put in. It drastically outperforms the US model. Plus, sugarcane alcohol from Brazil can reduce the total carbon footprint by up to 70% compared to standard gasoline. It's incredibly efficient. But, there's a catch. Brazil just can't supply the entire world because doing that would cut way too deep into critical natural areas and global food production. There's really only so much arable land to go around. So we've got to move beyond traditional agriculture, enter synthetic biology. Scientists like Jay Kiesling, who actually originally engineered yeast to produce low-cost, life-saving malaria drugs, realized something fascinating. That anti-malarial drug is a hydrocarbon. It's incredibly similar to diesel fuel. So now they're taking non-food crops like switchgrass that grows on marginal lands and turning them into second-generation biofuels. The whole process is kind of like a futuristic brewery. You extract glucose from the plant, feed it to some genetically engineered yeast, and then literally skim those high-energy hydrocarbons, the exact same compounds found in fossil fuels, right off the top to pump straight into your gas tank. How wild is that? But hold on. What if we didn't have to grow anything at all? The absolute ultimate theoretical frontier here is artificial photosynthesis. Materials chemists are actually trying to outdo nature's incredible process. Imagine a material you just unroll like a sheet of bubble wrap. It takes in sunlight and carbon dioxide. A catalyst breaks the chemical bonds of water. It vents pure oxygen back into the air, and out the bottom wicks a liquid or gaseous fuel that's completely ready for our cars and planes. We're talking about a completely self-contained, sci-fi level solar fuel generator. Moving on to Section 2, reinventing how we drive, the end of traffic. As we transition into this second pillar, we really have to confront the severe, glaring inefficiencies of our current infrastructure. The financial, emotional, and environmental costs of our daily commutes are simply enormous. Did you know the average American spends nearly 300 hours a year in a car, and 38 of those hours go absolutely nowhere? You're just sitting in traffic. I think we all know that universally shared misery, right? Well, that congestion alone burns through over $1 billion in wasted gasoline every single year in the US. And it's not just the big traffic jams. Simple human oversight plays a massive role too. For every single pound per square inch, or PSI, that your tires are underinflated, you are wasting 3% of your fuel efficiency. We clearly, desperately need to utilize our roads more intelligently. So this is where we totally change how our vehicles understand the world around them. Companies like Nokia are developing these next-generation 3D digital maps. They're mounting 64 rotating lasers, which is called LiDAR, along with sonar and 360-degree cameras straight onto vehicles to measure distances and constantly map the world. We're talking about collecting an incredible 1.3 million data points per second. In the near future, these maps are going to integrate topography, infrastructure, and live traffic data. So instead of just routing you for the absolute fastest time, the map is going to route your car based purely on maximum fuel efficiency, calculating exactly how the stoplights and traffic are moving at that exact second. Now, taking this a massive step further, we have autonomous vehicle technology. Look, by taking human drivers out of the equation entirely, we eliminate speeding, haphazard merging, and all that super inefficient driving. Companies like Scania are already out there testing autonomous heavy-duty trucks using a brilliant concept called platooning. Essentially, the vehicles communicate wirelessly and instantly. If the front truck hits the brakes, the others brake at the exact same millisecond. This allows them to drive unbelievably close together, behaving a lot like a perfectly synchronized school of fish, or, massive semi-trucks drafting in the Tour de France. And that drastically reduces air drag. The real-world impact of cutting down that air drag? It's huge. By platooning, these heavy-duty trucks can save roughly 10% on fuel. When you consider that driving at 65 miles per hour, almost 2/3 of a truck's energy is spent just literally pushing the air out of its way, that 10% ends up being roughly 8,000 euros saved per heavy-duty vehicle every single year. It's an absolute game changer for both the global economy and the environments. Which brings us to Section 3, Building Cities of Tomorrow, the Masdar City Experiment. This final pillar scales everything up to the actual environments these cars operate in. And this is a totally critical challenge when you realize we are globally building the equivalent of a brand new million-person city every single week. Let's look at a really fascinating laboratory for urban design, Masdar City, which is rising straight out of the Arabian Desert in the United Arab Emirates. The architects there literally looked backward into history to figure out how to move forward. They adopted ancient Arabic street design, creating these tightly packed, completely car-free pedestrian zones that naturally funnel the wind. By moving all the transportation underground into the actual bowels of the city and lifting the entire pedestrian plane up by 7 full meters, they managed to catch these cooling breezes that make walking around in the desert feel completely manageable. And the effectiveness of these design choices, it's just striking. Just a short drive away in downtown Abu Dhabi, the black asphalt can reach a scorching 57 degrees Celsius, or 134 degrees Fahrenheit. But on that exact same day, over in the shaded pedestrian zones of Masdar City, the ground is a totally manageable 33 degrees Celsius, about 91 degrees Fahrenheit. These simple yet totally brilliant architectural moves drastically lower the ground temperature, which ultimately slashes the entire city's air conditioning needs by a whopping 60%. Now, to power this pedestrian utopia, Masdar relies on heavily advanced renewable tech. Everything there is doing double duty. The roof panels, they don't just provide shade for the streets below, they're actively generating electricity. The walls themselves are actually built from glass-reinforced concrete made out of the very desert sand surrounding them. And maybe the most impressive part? They're testing a prototype solar beam down tower. So instead of using a bunch of expensive silicon panels, this system uses a massive field of mirrors to bounce the sun's rays up to a tower and concentrate them all down to a single intensely hot point. It reaches an unbelievable 600 degrees, generating steam that runs their electric turbines. Okay, time for a reality check though. Masdar isn't a completely flawless utopia just yet. Here's the grounded truth. Neither of these solar technologies actually works at night. When the sun goes down, Masdar currently still has to draw power from the natural gas grid, which means it isn't entirely free of fossil fuels today. But you know what? That doesn't mean it's a failure. Not at all. It makes the city a necessary living laboratory. The real payoff here won't just be having a single green city in the desert. The true payoff is going to be refining and exporting these incredible technologies and architectural lessons to existing cities all over the world. There's a local anecdote from the region that just beautifully encapsulates this whole overarching mission. It essentially frames humanity's management of the earth as a sacred trust. The story goes that this trust was offered to the mountains, the heavens, and the earth, and they all politely refused it. But man, being a bit adventurous and, let's be honest, perhaps delightfully vain, accepted it. And with that acceptance comes a profound, heavy responsibility to sustainably manage the planet we've inherited. All right, Section 4, the challenge of utopia. Charting our path. While achieving a perfectly flawless universal utopia where we live in total harmony with nature might be impossible, striving for it and actively deploying these incredible technologies is an absolute necessity as we chart our path forward. So, as we look ahead to the future, I want to leave you with a final thought to really chew on. How will your own city, your own local community, need to adapt these 3 pillars, its fuel, its driving, and its urban design, to actually survive the massive resource demands coming our way in 2050? Which of these revolutionary adaptations are you going to need to embrace first? Keep questioning, keep learning, and hey, thanks so much for joining me on this explainer.